Some tractors work fields, others move mountains. Today we're counting down the 10 biggest tractors ever built by mankind. From the legendary Big Bud that still dominates Montana fields, to modern production giants producing over 700 horsepower. From Canadian brutes, built for simplicity, to German engineering marvels with rotating cabs. And from American iron that defined what massive meant to tracked monsters that spread weight across Earth while pulling implements that smaller tractors cannot budge. These aren't everyday farm tractors. These are machines built when ordinary equipment wasn't enough and when farmers needed power that exceeded what conventional manufacturers offered, creating tractors that pushed boundaries and that redefined what agricultural equipment could accomplish. Number 10. Steiger Panther K525. The Steiger Panther KP 525 takes the 10th position as an early mega tractor from the 1980s, featuring a 19-liter Cummins diesel, producing 525 horsepower, and becoming iconic during an era when tractor size was exploding and when farms were consolidating into operations requiring equipment that previous generations would have considered ridiculously oversized, but that modern large-scale agriculture demanded when efficiency meant covering thousands of acres quickly, and when profitability depended on having equipment capable of working massive fields without being limited by power or by traction when pulling wide implements across varied terrain and varied soil conditions that demanded tractors built specifically for extreme applications, rather than being built for average farms, operating at scales that conventional equipment could serve adequately. The 19-liter Cummins engine represented serious displacement when most tractors were using engines half that size or smaller, creating a power plant that could sustain maximum output for extended periods without overheating and without suffering the mechanical distress that smaller engines experienced when working continuously under loads that would have destroyed less robust designs built for lighter duty than what the Panther was designed to handle. The 525 horsepower placed the Panther among the most powerful tractors available during the 1980s, when power levels were climbing rapidly as implement widths increased, and as working speeds increased, requiring tractors that could maintain momentum when conditions became challenging, and when stopping or slowing meant losing productivity that tight schedules could not afford, when planting windows or harvest windows demanded completing work before weather changed or before crop quality deteriorated from delays. The sheer size that characterized the Steiger Panther made it immediately recognizable when farmers saw the massive articulated tractor working fields where its capabilities justified the substantial investment that purchasing such equipment required, when prices reflected the engineering and reflected the construction quality that extreme tractors demanded if they were to survive the abuse that large-scale farming imposed on equipment that was working constantly under maximum loads, in conditions that ranged from ideal to terrible, when weather or soil created challenges that operators had to overcome rather than waiting for better conditions that might not arrive before critical work needed to be completed, regardless of difficulties. Number 9. AGCO Challenger MT 875E. The AGCO Challenger MT 875E takes the 9th position, featuring a 16.8-liter diesel producing 600 horsepower with power shift transmission, creating a massive track tractor built for extreme workloads when rubber tires would slip or would compact soil unacceptably, and when track systems distributed weight across larger contact areas, reducing ground pressure while maintaining traction that allowed pulling heavy implements through conditions where wheeled tractors struggled or failed completely, when soil moisture or soil type created situations where tracks were necessary rather than being optional luxury features that some farmers chose for marginal advantages. The 16.8-liter displacement reflected AGCO's commitment to building engines with reserve capacity, ensuring that sustained operation under maximum load would not stress components beyond design limits. When running at 100% power for hours or days, created wear and created heat that smaller engines could not manage without failures that would leave operators stranded and would create repair bills that could exceed the costs of building tractors properly from the beginning, using components designed for applications, rather than being designed for lighter duty and then being pushed beyond capabilities, when farmers demanded performance that manufacturers had not anticipated during design phases. The reserve capacity that larger displacement provided meant that the engine could produce 600 horsepower while operating at power levels that left margin for peaks and left margin for variations in load when pulling implements through changing soil conditions, or when working slopes that temporarily increased resistance. requiring brief power surges that engines operating at absolute maximum could not provide without damage, when combustion pressures or when bearing loads or when other stresses exceeded what components could withstand during sustained operation at levels that destroyed engines lacking adequate capacity for the work being demanded. The heat management that larger engines provided through greater surface area and through larger cooling systems allowed dissipating thermal energy that smaller engines accumulated when working hard, creating temperature rises that degraded lubricants and that expanded metals beyond clearances that engineers had specified when designing components that needed to maintain precise tolerances for sealing and for bearing function and for other critical relationships that excessive heat disrupted when temperatures exceeded design parameters that manufacturers had established based on expected operating conditions rather than based on extreme conditions that farmers routinely imposed when working against deadlines that made reducing loads or reducing speeds impractical when crops needed attention, regardless of what equipment manufacturers had assumed about how tractors would be operated. The durability advantages that building engines large enough for applications rather than building engines barely adequate for rated outputs created lifetime cost benefits when tractors that were properly engineered from the beginning lasted decades rather than lasting years before requiring major rebuilds or before requiring replacement, when accumulated abuse finally exceeded what marginal designs could withstand, no matter how carefully operators maintained equipment that was fundamentally inadequate for the work being demanded. The fuel efficiency that seemed counterintuitive when larger engines appeared wasteful actually favored properly sized power plants, when engines working at comfortable percentages of maximum capacity operated more efficiently than smaller engines working constantly at maximum capacity, where fuel consumption per horsepower hour was higher and where component wear per hour of operation was dramatically higher, creating false economies when purchasing smaller tractors that appeared cheaper initially, but that cost more over their shortened service lives than larger tractors cost when total ownership expenses, including repairs and including replacement timing, were calculated honestly. The engineering philosophy that AGCO embraced when building the MT875E reflected understanding that agricultural customers valued long-term reliability over initial purchase price, when farmers who depended on equipment for their livelihoods could not afford failures during critical periods and could not afford the downtime that inadequate equipment created, when breakdowns occurred at moments when crops demanded attention and when weather windows were closing, making equipment availability more valuable than any savings that cheaper alternatives might have provided when purchase decisions were being made. The competition from other manufacturers building mega-tractors forced AGCO to ensure that the MT875E could match or exceed what Claas Xerion and what John Deere and what other competitors offered when customers compared specifications and when customers evaluated track records that established which manufacturers built tractors that truly lasted and which manufacturers built tractors that merely looked impressive until real work exposed weaknesses that proper engineering would have prevented if manufacturers had been willing to invest in components and in designs that prioritize durability over cost reduction. The 16.8-liter engine's architecture included features that smaller engines often lacked when AGCO specified components including forged crankshafts and including heavy-duty connecting rods and including robust main bearings that could withstand forces that 600 horsepower created when transferred through reciprocating masses and when transferred through rotating assemblies that needed to survive millions of revolutions under loads that would have shattered components built to lighter standards that cost-conscious competitors might have specified when attempting to reduce manufacturing expenses, even when such reductions created reliability problems that would surface only after warranties expired and after manufacturers had collected revenues without suffering consequences that customers would bear when expensive failures occurred. The serviceability that AGCO designed into the MT875E recognized that mega-tractors needed to be maintainable in field conditions when transporting equipment weighing tens of thousands of pounds to dealer shops was impractical, and when farmers needed to perform routine maintenance and needed to perform minor repairs without requiring specialized facilities or specialized tools that only dealers possessed, creating dependencies that mega-farm operators found unacceptable when their scale and when their investments justified maintaining in-house mechanical capabilities that could keep equipment running without relying on external support that might not be available when needed during critical periods. The reputation that the MT875E established among farmers who operated the tractors across thousands of hours and across multiple seasons provided validation that AGCO's engineering approach was sound and provided evidence that properly designed megatractors could deliver the reliability and could deliver the productivity that justified their substantial purchase prices when total value over equipment lifetimes was considered, rather than just considering initial costs that made smaller or cheaper alternatives appear more economical, when ignoring the reality that inadequate equipment created opportunity costs and created failure risks that far exceeded any initial savings that marginal designs might have offered. The 600 horsepower output positioned the Challenger among the most powerful tractors available when AGCO recognized that farmers managing mega operations needed equipment matching their scale and matching their ambitions when attempting to work efficiently across acreages that dwarfed what family farms had historically managed, and when competition from corporate agricultural operations demanded that independent farmers mechanize at levels that would allow competing against entities with resources that individual operators lacked, but that could be partially offset through purchasing equipment that maximized productivity per operator, allowing smaller crews to accomplish what larger crews would be required for, that was simply too small for the tasks that modern large-scale agriculture demanded. Number 8. Challenger MT975B. The Challenger MT975B takes the 8th position as one of the largest tractors ever produced by Caterpillar's Challenger brand, featuring a Caterpillar diesel, producing 570 horsepower with 16-speed power-shift transmission, creating a machine that combined Caterpillar's construction equipment expertise with agricultural requirements. When the company recognized that farmers needed tractor capabilities approaching what mining and construction demanded from equipment working under extreme conditions, and when Caterpillar's reputation for building durable machinery created opportunities to enter agricultural markets where durability and power were valued more than comfort or convenience features, that smaller tractors emphasized when competing for buyers who prioritized different attributes than what megafarm operators needed when selecting equipment. The Caterpillar diesel engine brought construction-grade durability to agricultural applications when farmers discovered that engines designed for continuous operation in construction and mining could survive agricultural use that destroyed engines built to lighter standards. When cost considerations or design compromises created weaknesses that extreme use exposed through failures that would not have occurred if components had been designed initially for applications, rather than being designed for average conditions, that megatractors exceeded constantly when working at capacity rather than working at the partial loads that average tractors experienced during typical operations on typical farms. The 570 horsepower provided pulling power that allowed working with implements that conventional tractors could not handle when chisel plows or when disc harrows, or when other tillage equipment required forces that only the largest tractors could generate through combinations of power and weight and traction that the Challenger's tracked configuration provided when distributing weight across rubber belts, rather than concentrating weight on tire contact patches, created ground pressure advantages while maintaining traction that allowed transferring power to implements, rather than spinning tracks uselessly when conditions were challenging and when operators needed to maintain working speeds, regardless of resistance, that implements encountered when working variable soils or variable terrain. Number 7. Claas Xerion 5000. The Claas Xerion 5000 takes the 7th position from Germany, featuring a Mercedes-Benz 12.8-liter diesel producing 530 horsepower, with continuously variable transmission and unique rotating cab design, creating versatility for heavy field work. When the German manufacturer recognized that extreme tractors needed capabilities beyond what conventional designs provided, and when the rotating cab allowed operators to face rearward when working with rear-mounted implements, or to face forward when working with front-mounted equipment, creating ergonomic advantages and creating visibility advantages that conventional cabs could not match, regardless of mirror systems or camera systems that attempted providing visibility without the direct sightlines that rotating cabs achieved. The Mercedes-Benz diesel brought automotive refinement to agricultural applications, when Claas partnered with the German automotive manufacturer to develop engines that combined power with smoothness and with efficiency that purely agricultural engines sometimes lacked when design priorities emphasized robustness over refinement, and when agricultural manufacturers built engines that worked reliably, but that did not match the sophistication that automotive applications demanded, when buyers expected performance characteristics that agricultural buyers historically had not prioritized, because reliability mattered more than smoothness, and because cost mattered more than refinement, when farmers were purchasing tools rather than purchasing experiences. The continuously variable transmission eliminated gear changes and eliminated the power interruptions that conventional transmissions created when shifting between ratios, creating seamless power delivery that allowed maintaining optimal engine speeds, regardless of ground speed, when working conditions or implement requirements demanded specific speeds that conventional transmissions could not provide without compromising engine operation, or without accepting inefficiencies that continuously variable systems eliminated through infinite ratio adjustments that kept engines operating at optimal points across the full range of working speeds that agricultural applications demanded when tasks varied and when conditions changed, requiring flexibility that conventional transmissions could not provide. Number 6. Fendt 1167 Vario MT. The Fendt 1167 Vario MT takes the 6th position as Europe's most powerful tractor, featuring a manned 6-cylinder diesel producing 673 horsepower, with Vario drive continuously variable transmission combining size with advanced technology. When the German manufacturer recognized that European mega farms needed equipment matching American scale, but needed refinement and needed efficiency, that purely American approaches sometimes sacrificed when emphasizing raw power over sophistication, and when European agricultural conditions and European agricultural practices demanded tractors that were powerful, but that were also precise and that were fuel efficient, when European diesel prices and European environmental regulations created different priorities than what American manufacturers faced when developing equipment for different markets with different requirements. The Mayen diesel engine represented industrial-grade construction when Fendt partnered with the German engine manufacturer known for building power plants for trucks and for industrial applications, requiring durability and requiring power delivery across wide operating ranges, when agricultural applications demanded engines that could work efficiently at partial loads and could work powerfully at maximum loads, creating versatility that purely agricultural engines sometimes lacked when designed specifically for narrow operating ranges that manufacturers assumed would characterize typical use. But that did not match reality when farmers used equipment across diverse applications requiring capabilities that narrow designs could not provide without compromises. The partnership between Fendt and Mayen reflected recognition that leveraging existing industrial engine development rather than creating agricultural-specific power plants allowed accessing engineering resources and accessing testing that purely agricultural manufacturers could not afford, when industrial engine volumes justified investments in advanced technologies, including common rail fuel injection, and including sophisticated turbocharging, and including electronic engine management that agricultural-only manufacturers would have struggled to develop independently when agricultural tractor volumes were modest compared to truck and industrial equipment markets that MAN served globally. The 673 horsepower that the MAN 6-cylinder produced demonstrated that modern diesel technology could extract extraordinary power from relatively compact engines, when turbocharging and when intercooling, and when advanced combustion management allowed achieving power densities that naturally aspirated engines, or that older turbocharged designs could not approach without reliability compromises that would have made such power levels impractical for sustained agricultural use, where engines needed to work at maximum output for extended periods, rather than experiencing the intermittent duty cycles that highway trucks typically encountered. The torque characteristics that the MAN engine delivered matched agricultural requirements when low-end torque for starting heavy implements, and when mid-range torque for maintaining working speeds, and when high-end power for maximum productivity combined to create power curves that were ideally suited for the varied demands that farming imposed when working conditions changed constantly and when operators needed engines that responded predictably across the full operating range without the peaky power delivery that some high-performance engines exhibited when optimized for narrow RPM ranges. The emission compliance that MAN engines achieved through advanced exhaust aftertreatment and through sophisticated engine management allowed Fendt tractors meeting European emission standards that were stricter than American standards, demonstrating that power and environmental responsibility were not mutually exclusive when proper engineering created engines that were both clean and capable, rather than requiring compromises that earlier emission control attempts had imposed, when less sophisticated technologies reduced power or reduced efficiency or reduced reliability when attempting to meet regulatory requirements. The global parts availability that MAN's industrial presence ensured meant that Fendt 1167 Vario MT owners could source components through MAN's extensive service network, rather than depending solely on agricultural dealer networks, creating redundancy and creating options that pure agricultural engines lacked, when parts availability determined whether breakdowns would be measured in hours or in days or in weeks, when critical components failed and when farmers needed tractors operational immediately rather than waiting for parts to arrive through agricultural supply chains that were sometimes slower than industrial supply chains serving customers whose downtime costs justified maintaining extensive inventories. The Vario Drive continuously variable transmission represented Fendt's commitment to efficiency when the German manufacturer recognized that eliminating power losses through gear changes and through torque converter slippage would create fuel savings that would accumulate across thousands of operating hours, making the more expensive continuously variable system economically justified, despite higher initial costs, when total ownership costs, including fuel, were considered rather than just considering purchase prices that made conventional transmissions appear more economical when ignoring operating expenses that would exceed any initial savings that simpler transmissions provided. Number 5. Versatile 620 DT. The Versatile 620 DT takes the 5th position as a Canadian-built powerhouse, featuring a Cummins QSX 15-liter engine producing 620 horsepower with 12-speed power-shift transmission, and becoming known for brute strength and simplicity when the Canadian manufacturer recognized that farmers managing prairie wheat operations and managing other large-scale grain production needed tractors that emphasized reliability and serviceability over complexity and over features that might fail when conditions were harsh and when dealer support was distant, creating situations where simpler designs that farmers could maintain and could repair themselves were more valuable than sophisticated designs offering marginal performance advantages but creating maintenance challenges that offset any benefits when breakdowns occurred during critical periods. The Cummins QSX 15-liter engine brought proven industrial reliability to agricultural applications, when Versatile chose an engine that had demonstrated durability in trucking and in other demanding applications, rather than developing proprietary engines that might offer advantages, but that would create parts availability challenges, and would create knowledge gaps when farmers and mechanics lacked experience with unique power plants that required specialized training and specialized tools that conventional engines avoided when using components and using architectures that were familiar and that were supported through extensive parts networks that Cummins had established across North America and across international markets where agricultural equipment operated. The 620 horsepower positioned the Versatile among the largest production tractors available when Canadian wheat farmers needed equipment capable of pulling air seeders and pulling other implements across sections or across multiple sections in single passes, when efficiency demanded minimizing trips across fields, and when soil conservation demanded reducing compaction from repeated traffic that conventional equipment created when narrower implements required more passes for covering the same acreage that wide implements could cover in fewer trips when pulled by tractors powerful enough and heavy enough for managing the forces that wide implements created when working thousands of acres during narrow planting windows that prairie weather imposed. Number 4. New Holland T9.700. The New Holland T9.700 takes the fourth position, featuring a 12.9-liter Cursor diesel producing 700 horsepower with 16-speed power-shift transmission, creating one of the largest tractors in New Holland's lineup and dominating large-scale farming. When the manufacturer recognized that competing in mega-tractor markets required building equipment matching or exceeding what competitors offered, when farmers compared specifications, and when horsepower numbers influenced purchasing decisions. Even when real-world performance depended on factors beyond raw power, including traction and weight distribution and implement compatibility that specifications alone could not capture, but that marketing emphasized when differentiation among similar tractors was difficult, and when horsepower became the metric that buyers used when evaluating options. The 12.9-liter Cursor diesel represented Fiat Powertrain Technology's commitment to building engines specifically for agricultural applications. When the Italian manufacturer recognized that adapting truck engines or adapting industrial engines created compromises that purpose-designed agricultural power plants could avoid when torque curves and when power delivery and when cooling requirements differed between applications and when optimizing for agricultural use, rather than compromising for multiple applications, created engines that performed better and that lasted longer when working under conditions that farming imposed, including dust and dirt and moisture, that industrial or highway applications did not encounter at levels that agricultural equipment experienced constantly. The 700 horsepower placed the T9.700 among the most powerful production tractors available when New Holland competed directly against Case 1H and against John Deere and against other manufacturers, building mega tractors for customers who needed maximum capability and who were willing to pay premium prices for equipment that would not limit their operations, when ambitious plans required having tractors that could handle whatever implements were needed and whatever conditions were encountered during seasons when completing work on schedule determined whether operations would be profitable or whether delays would create losses that could not be recovered when markets or when crop quality suffered from timing problems that inadequate equipment had created. Number 3. John Deere 9RX640. The John Deere 9RX640 takes the third position as Deere's biggest production tractor, featuring a 15-liter Cummins diesel producing 640 horsepower with the 18 power-shift transmission and designed for mega farms. When the iconic green and yellow manufacturer recognized that competing in markets for the largest tractors required building equipment that matched the capabilities and matched the sophistication that customers, managing operations spanning tens of thousands of acres, demanded when conventional tractors simply could not provide the power or provide the features that such operations needed for remaining competitive against corporate agricultural entities that were investing heavily in the most advanced equipment available and that were achieving efficiencies that independent operators needed to match if they were to survive in industries where margins were thin and where productivity determined who succeeded and who failed. The 15-liter Cummins diesel brought proven reliability to Deere's largest tractor when the partnership between America's most famous tractor manufacturer and America's most famous diesel engine manufacturer created a combination that buyers trusted based on reputations that both companies had established across decades of building equipment, that farmers depended on when livelihoods were at stake, and when equipment failures could create catastrophic losses during critical periods, when planting or harvesting could not be delayed without suffering consequences that would affect entire seasons and that would affect entire years, when crop revenues depended on timing, that adequate equipment made possible, but that inadequate equipment prevented. The 640 horsepower provided pulling power for implements that were measured in widths approaching or exceeding 100 feet, when air seeders and when tillage equipment designed for covering maximum acreage in minimum time required tractors that could maintain working speeds regardless of resistance that soil conditions created and regardless of slopes or terrain variations that would have forced smaller tractors to slow down or to stop completely when encountering conditions that the 9RX640 could work through without hesitation, when weight and when traction and when power combined to create a machine that was simply unstoppable when properly operated by skilled operators who understood how to maximize productivity from equipment that represented million-dollar investments, requiring careful management and requiring maintenance that ensured availability when needed, rather than allowing neglect that would create failures during periods when downtime was unacceptable. Number 2. Case International Harvester Quadtrac 715. The Case International Harvester Quadtrac 715 takes the second position as currently the most powerful production tractor in the world from 2023 to present, featuring a 15.9-liter FPT cursor diesel producing 778 horsepower with power drive power shift transmission, when Case IH recognized that maintaining leadership in mega tractor markets required building the most powerful tractor available and required demonstrating technological capabilities that would justify premium pricing and would attract customers who wanted the best regardless of cost when managing operations, where equipment capabilities directly determine productivity, and where having the most capable equipment available created competitive advantages that justified investments that smaller operations could not consider, but that mega farms required when competing globally in agricultural markets where efficiency determined survival. The 15.9-liter FPT cursor diesel represented the pinnacle of Fiat powertrain technology's agricultural engine development, when the Italian manufacturer built an engine specifically for extreme agricultural applications, requiring sustained maximum output under conditions that would have destroyed engines built to lighter standards, and when power density and when durability and when efficiency all needed to be optimized simultaneously, rather than accepting compromises that simpler designs involved when building engines for less demanding applications that did not require the sophistication that the cursor delivered, through advanced fuel injection and through advanced turbocharging and through advanced cooling that allowed extracting 778 horsepower from 15.9 liters of displacement. The 778 horsepower established new standards for production tractor power, when Case IH demonstrated that larger engines and larger tractors were feasible and were marketable when customers existed who needed such capability and who were willing to invest in equipment that represented the absolute cutting edge of what agricultural engineering could achieve, when cost was secondary to capability, and when farmers managing operations spanning continents rather than spanning counties needed equipment that matched their scale and matched their ambitions when attempting to compete in global agricultural markets, where American farmers faced competition from operations in South America and in Australia and in Eastern Europe, where land was cheaper and where labor was cheaper, creating cost advantages that American farmers needed to offset through superior equipment and through superior management. Number 1. Big Bud 16V 747. The Big Bud 16V 747 takes the top position as widely recognized as the largest farm tractor ever built from 1977 in the United States, featuring a 16-cylinder Detroit diesel, producing between 1,100 and 1,350 horsepower, weighing approximately 100,000 pounds, and remaining operational in Montana, when the custom-built machine demonstrated that extreme agricultural equipment could be practical and could be reliable when properly engineered and when applications justified the extraordinary investments that building such machines required when conventional equipment simply could not provide the capabilities that certain farming operations needed for working at scales that exceeded what production tractors could serve, regardless of how large those production tractors were, when even the biggest factory-built equipment fell short of what custom applications demanded. The 16-cylinder Detroit diesel represented an engine designed for heavy trucks and for industrial applications, rather than being designed specifically for agriculture. But the power plant's reputation for reliability and the power plant's ability to produce over 1,000 horsepower made it ideal for a tractor that needed to operate continuously under maximum load, when pulling implements that were measured in widths approaching 100 feet, and when working thousands of acres during narrow windows that weather imposed, creating situations where downtime was unacceptable, and where power reserves were necessary for maintaining productivity, when conditions became challenging and when stopping or slowing would have meant failing to complete critical work before weather changed or before soil conditions changed, making work impossible until conditions improved, which might not occur until opportunities had passed. The 1,100 to 1,350 horsepower that the Big Bud produced, depending on configuration, exceeded what any production tractor has ever offered, when even the most powerful modern tractors producing 700 or 800 horsepower fall far short of what the Big Bud achieved through custom engineering and through using an engine that was designed for entirely different applications, but that worked beautifully in agricultural use when properly integrated into a tractor designed specifically around the engine's characteristics and around the forces that such power would create when transferred through drivetrains and through final drives to tracks that distributed the tractor's enormous weight across contact areas that prevented the big bud from sinking into soil, despite weighing 100,000 pounds, when track systems spread loads, and when engineering ensured that ground pressure remained acceptable, even when total weight exceeded what most agricultural equipment would ever approach. These 10 biggest tractors ever built represent humanity's ambition to dominate land through mechanical power, when farming at scales that earlier generations could not have imagined required equipment that earlier generations would have considered impossible or impractical, but that modern megafarms depend on when managing operations that feed nations and when competing in global markets, where efficiency determines who survives and who fails. From the legendary Big Bud to modern production giants, these tractors prove that size matters when applications demand maximum capability regardless of cost. Which of these massive machines would you want pulling your implements? Share your thoughts below and subscribe for more stories about the equipment that powers modern agriculture and that allows feeding billions through mechanization that continues pushing boundaries that each generation believed were limits until the next generation proved otherwise.